Hello and welcome back. We have something to repair once again. It's that time again. We got a broken PS4 Slim this time. As you can see, there's a note on it, bright note that says it's broken. I have power plugged into this thing, and I think this is supposed to be on no power. Let's find out. Eject does nothing. Power does nothing. What if I try to insert a disc in it? Just to be thorough. There's a disc in it, I believe. Okay. So yeah, I think we got a disc in there. So that's where we are. Let's get into this thing and see what's wrong with it. Oh, and I should mention, it's rather dirty. You can see down in those grooves, the vent holes. But the warranty seal is still intact. So no one's been into it yet. Nice. Well, I got the bottom off, and yeah, she's a little dirty. Not that that should keep it from working. Not really seeing any roach signs yet, just dirt. Let me get this blowed out a little bit, and we'll get that power supply swapped out. Well, I swapped out the power supply. I've got my known good test supply in here. Let's see if we have any signs of life. Now, we're plugged in back there. Got the monitor on in case it comes on. Oh, I hit eject, and it powered on because there's a disc in there. And it's struggling to eject it. Yeah, I don't even see it trying. But this is also a little bit, it comes a little bit bowed, looks like. The Lion King, it's a movie, okay. This looks a little bit bowed. That could be part of our issue as far as that, you know, see how it's springy? Have to straighten that a little bit maybe. But we have power. Still don't have a white light. Oh, there we go. There's a white light. Video. It acts like it doesn't have a hard drive in it, but it does have a hard drive. It may not be a good hard drive, but it has one. What are the odds we have a dead power supply and a bad HDMI? It's possible. Solid white light, but still nothing on the monitor. Oh, it's trying to lock. We've got an intermittent HDMI, don't we? Oh yeah, intermittent HDMI cannot access storage, so it probably just means they took the hard drive out and they erased it on the computer, so it's blank. There we are. I think we're going to be good. We've got to fix this other power supply here. Straighten out some of this bending here. Probably replace an HDMI connector. Let me wiggle this. Yep. Yep. So bad HDMI connector too. Okay. Let me get this apart and we'll get on with it. Oh, well, I want to take it apart. I wanted to share with you why it says there's no hard drive. If you look down in there, there's the contacts of the hard drive. It's backwards. They put it back in the little caddy backwards for some reason. Oh well. That explains that. Well, welcome inside to my workbench. Let's see if we can figure out what's going on with this power supply. That is not doing its job. And once again, I do not recommend doing this unless you are familiar with working with, electricity, because it will bite you. Don't believe this one's ever been opened. Really? Okay. There's that. Huh. Why is that got a circuit board? Looks like it's damaged down in there. Like somebody stuck a screwdriver into it or something. I don't know if it's going to show up on camera too well. Just see. Right in there. Yeah, there's ripped traces right there. Oh, that's interesting. Wonder how that happened. I haven't put a screwdriver into this thing. I was just using my fingers. So that has been gouged right there, and that would probably kill any hope of the supply starting up. Let's take a look at this under the microscope, maybe. Get a little better view of the damage. Oops, if I can get my microscope camera to start recording, because the remote is an absolute piece of garbage. Let me slide this forward. Alright, what do we have now? Try to get that into focus. We have 2 ripped traces. I'm not sure how this happened either. It is springing back up every time I squeeze it down. We can press that down a little. I'd like for it to stay somewhat flat. Well, let's see if we've done any good with this supply. I'm hoping that was the only problem it had. Let's see, where's my AC power? Right here. All right. Here's our standby connector. Let's just see. Get ground right there. 5 volt standby here. What do we have? 4.8. Excellent. Let's just go ahead and check the 12 right quick like. I got a feeling she's going to work. Or maybe not. Am I not making a good connection? Okay, no 12 volts. Did our 5 volts shut down? 5 volts is still there. What gives? Nothing. Which is odd because if I'm making a good connection, the 12 volts should have tried to come on. If it had failed, normally the 5 volts would shut down also. Alright, so where are we now? I repaired that broken trace there. But that wasn't all of our issues. We have another issue. Of course, 5 volts is working fine. 12 volts does not. And let me try to show you what I've been chasing here. So when the 12 volts is enabled, what you get is the 5 volt standby. Well, effectively the what was it labeled? AC/DC standby has to go high to enable it. Normally that's like 3.3 volts that comes out of the power supply. I mean, it comes out of the motherboard. Comes back from the motherboard to enable the 12 volts. So normally it'd be like 3.3, but you can jumper like I've been doing between the 5 volt standby and that and the AC/DC standby input, which is on this third pin right here, and it will come on. But it hasn't been coming on. But what normally should happen, that 3, 4, 5 volts, however many you connect right here, would normally come in, goes through a resistor, goes to pin 1 of this DNP12, pin 1, and then it ends up, if everything is, we don't fully know the function of this chip, but it oversees basically the power supply. If everything's good, it will then take that high and send a high out pin 7. And that high coming out pin 7 ends up turning on this opto-isolator, optocoupler, photocoupler, whatever you'd like to call it. It ends up, I shouldn't say, it pulls down low. The anode side is tied to 5 volts through a resistor, pin 1. The other side gets pulled low by this IC. So that carries the signal from here, in here, out, and then you end up getting over here. This is basically like an NPN transistor on this side of this device, with the base being sensitive to light. So what normally should happen, I'm getting on a ground over here, there is a 15 volt supply running on this side, and you'll see it right there, 15.2 volts. That is a supply voltage for this DAP46 here. It's using that to run. That same voltage though comes over to this opto-isolator, goes in, and when it's enabled, when it's turned on, when you get light going across inside this thing, you get that 15 volt switched to this other pin. This is basically the collector on the right, emitter on the left, and the emitter would then carry that over to the base. Well, there's probably a resistor in there somewhere, but a little transistor right here, Q41, I believe it is. And that transistor, when it's turned on, is responsible for switching the 15 volts to these other ICs down here, the ones that are responsible for generating the 12 volts. they're responsible for turning on the what's the word I'm looking for? Shoot, it escapes me at the moment. Power factor corrector. That's what I was looking for. It enables the power factor corrector IC and the IC that controls the 12 volts. So they're sitting there idle right now in 5 volt standby. But let me show you what's happening. If I jumper pins 1 and 3 on this little connector to enable the 12 volt supply. Okay. Like if I go over here now, this is the cold side of the supply. There's pin 3, which I'm not getting a good contact. Come on, get in there. Still not. Oh, do I have 5 volts? Oh, my 5 volts shut down that time. No, it didn't. Connection problems? Okay. Do we have a connection problem here, I wonder? Something intermittent? That's very suspicious, but of course I'm taking my ground off. Anyway, 4.8 comes over here to pin 1 through a 7.5 k ohm resistor, 4.35, and ends up being turned into a low down here on pin 7, which is going over to this optocoupler right here. And the 5 volts is shutting down now, isn't it? No, she's stable. Let me go over here. That control voltage is going up and down though. And what I was going to show you is that resulting 15 volts over here with different ground is going up and down, like a yo-yo, up and down. So I don't know why it's doing that. It looks like the 12 volts is trying to come on and it goes, nope, nope, nope. All right, I'll try again. Nope, nope, nope. So there may be a short somewhere. Something is broken somewhere because that should not be going up and down. That's cycling up and down. Very interesting though. So I got to figure out why it's doing that. Alright, well I'm trying to find out why this 12 volts does not work on this supply. And I've decided to try another approach. And what I'm doing is I have, this is called a, they call it a fault locator, a curve tracer. Curve tracers have been around for a long time, but they've gotten a lot smaller and a lot simpler. And the beauty of this thing is that it's a 2-channel curve tracer. So the usefulness of it is, though, if you have 2 identical circuits that you're comparing, it makes it fairly quick to go through and just compare the waveforms generated by each point. And they should be identical. If the circuits are identical, it should be identical response on the screen here. If it's not, then that tells you need to take a look in that area. And I've used it a few times. I don't think I've ever used it on a video before, but we're going to give this a try. And I should tell you, I have thoroughly discharged the capacitors on both these boards, because nothing will kill this thing quicker than providing a couple hundred volts DC in on its input. It does not like that, and we don't want to kill it. So I have discharged the capacitors thoroughly. Should be safe there. This is an identical working board up here, and this is the yellow waveform. I wonder if I can turn the light off, if that would help. I don't know if I'll be able to see. That'll help things show up better. This is a good board. a 160 FR, I believe it is, and this is another 160 FR. This with the check mark works, and this will be the yellow waveform here. Like if I put this, let me get the wrong one. Yeah, this one. This should be a yellow waveform. You'll see right there, and this one should give a red waveform. And if I pick a point here, you can see, and it will overlap them, so it makes it easy kind of. So we're going to make some comparisons. So yellow is the good reference board up here, and red is our suspect board. So I'm going to start on this DAP 46 here, pin 1, right up here, and you can see it gives a response of it. And if I go to that same point down here, I'm not getting a response. I'm not getting any kind of change in the waveform, which is very odd. I mean, it's like there's nothing connected there. But these circuits should be identical. Let me go down to pin 2. Pin 2 looks like it's got some kind of capacitance hooked to it. Yep. Pin 2 is going to be very similar, I believe. I think my probe's about broken here. Oh, it's come loose. They thread in there, and apparently they thread out too sometimes. Pin 3 acts like it's just hard connected to my ground reference. It may be ground. Well, maybe I'm giving you the wrong pin numbers. I hate to give you the wrong pin numbers. Let me look right quick. Okay, yeah. So I'm wrong. Pin 1 is up here on this corner, in the upper right corner. So 1, 2, 3, 4, 5, 6, 7, 8. It's a 16-pin chip. So this has been. We started on pin 9. Pin 9. They do not look the same. 10, 11, 12 did about 13. 13 looks similar. Very similar. 14 is not used. Is that 14? I'm still getting off of my count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 looks the same. 13 is not used. 14 has a really odd looking waveform, but they're roughly similar, but there's something different there. It looks like the capacitor is charging up now. They're going to be very similar when the capacitor charges up. Okay, keep going. 15, very similar. 16, very similar. So 9, though, is a bit curious there. I mean, you can see on this waveform, there's a junction, semiconductor junction here, and a semiconductor junction there. So something conducting in both directions on pin 9 of this board, but on this board, it's like it's open, like there's nothing connected there. I get no response. Okay, keep that in mind. Let's move on to the. This is the power factor correction. 1612A3, I believe it is. Pin 1. You see a junction there. Looks identical. And it gives you an approximate percentage of how close they are to each other. And it says 3.5%. 2. Oops, if I can get on there. 3.2%. They're very, very close. 2% tolerance. This is pin 4. Yep. Pin 5. Identical. Pin 6. Identical. 1%. 7. 8. If I can make contact, 8 is good. 9. Well, yeah. 9. Yeah, 9. Oh, 9 is very low resistance to ground. And 10, identical. So those look very, very similar. We could even look on, like, say these FETs over here if we wanted to. If I can remember where they are from this side of the board. But I have a feeling we need to focus our attention on pin 9 of this DAP46. Alright, I've been doing a little bit of investigating. Trying to figure out what's going on here. Let's look under the microscope at this circuit. I know I was calling this a DAP46 earlier. It's obviously a DAP49. This pin here, pin 9 of this IC, is where we could see the circuit tracer waveform on one and not the other. So that may be important yet, but it doesn't go anywhere. I followed it, goes through a jumper here, over here, and basically to some unpopulated areas. These pads have nothing on them. So that's not really our problem, but it could be indicative of another problem. Something going on in this IC, because it doesn't connect to anything externally, but there should be an internal junction, something going on there. Because what we were having was our 15 volt switch supply that comes over here was going up and down, up and down, up and down. And I followed that, and that is pin 10. Yeah, right here. Get in the picture. Pin 10. This is pin 10. That's the supply into this chip. And if I measure from ground to this point, I get 11 ohms. And this Zener right over here, this one, what's its number? ZD31, I measure that same 11 ohms. So this is across that power supply. Now, is that Zener bad? Or is it this IC? The IC that we didn't have a junction in earlier, on this pin. Although it's not used, it's still hooked to something internal and appears to be open. And I mean, also something I have to keep in mind is this IC up here shares that same supply. So it's possible it could be what's loading it down. It's possible. Because they're switched on together. They both get that 15 volts switched at the same time. I'm going to go with my gut on this one and say this IC. So let's pull that off and let's see if our short goes away across this Zener over here. That's as good a place as any to start. quick check now that the chip is out. Get everything in the picture. We're in continuity mode. Here's that zinger that was across the supply. And it is no longer reading shorted. If I go to diode mode, do I read 6/10 there? Yep. So the zinger was fine. It was our IC. So let's see if we've got a DAP49 laying around. That may take care of it. Well, the IC's been changed out. The DAP49. We are at a point of testing. See if we get our 12 volts. Let me get some power into this thing. This power is switched off at the moment. I'll switch it on in just a second. I've got my load connected. Let's see everything. Let's see if we have our 5 volts. AC power is on. Ground. 5 volts. 4.8. Close enough. And let me get, because the way you're set up right now, the camera's set up, you can't see the load. So let's see if we get our 12 volts now. Well, if I can maintain contact. I think she's shutting down. Yep, she's shutting down. She goes to, well, no. If I make contact, it does fine. 11.9. We're drawing 6 amps. It's just hard to keep contact this way. Maybe I should use my little jumper wire I've made up here. I bet that does better. Look at that. Surprise, surprise. That has a wire between 1 and 3. And there we are, 11.9 volts. Solid. I think our supply is fixed. Just need to take a quick look at that HDMI port. I looked at it earlier and I didn't see anything really bad shape on it. It does look very dirty. May still replace it, but it just looks dirty. There's like yucky stuff on the pins inside, just grease and nastiness. So, but I think our supply is going to be good. Let me take a quick look at that HDMI port. We may be ready to test. That looks really good. We are back out in the garage and we are at the point of testing to see if we've done any good here. I have not put it back together fully. As you can see, I don't have the bottom plate on it yet. But I did go ahead and clean up the chassis while I had it apart. Clean the Blu-ray, clean the rollers real well, new thermal paste. Let's see, what else? I did not replace the HDMI port. I've just cleaned it. I may regret that because I'll have to take it all back apart again if I still need to change it out. But our repaired supply is in there. Let's see if we've done any good. Well, a beep is good. monitor has locked. The hard drive, you know, I showed you earlier, was mounted in the caddy backwards. I took it out and reversed it and took it inside and checked it. Checked the smart data. And it's perfectly healthy. No reallocated sectors. It's a perfectly healthy drive, so I'm not sure why it was stuck in the cage like that. It looks like it's checking the hard drive now. I don't know why it was stuck in there like that, but this is looking promising. Always takes forever when you're watching it. I need to check. Well, let me get some video coming back to it. We'll wiggle this connector to make sure it doesn't go flaky as everything. I think our power supply is going to be healthy. There's that logo. All I have to do is tilt down and the logo pops up. It's magic. Can I wiggle this? Rock solid. Okay. I cleaned that with some, cleaned it really well with a swab, cotton swab with alcohol, and then went back with the, what's it called? Deoxit cleaner. And we are up and running.
Area. L1 button to the left hand. R1 button to the right hand. Press the down button.
Voice prompts are on. That's irritating.
Press the up button to move to the function screen where you can select system functions.
Okay, it's through talking. Okay, I think we have a working machine. Let's see, all that's left to do, make it official. Stick this on here. No. Repaired. And I'm trying to do this. And hold it with one hand. There. It's official. It's fixed. I hope you found that somewhat interesting, educational, informative, something. If you did, please give me a thumbs up. And I will see you in the very next repair. Bye for now.